let's take a look at solving exponential functions, equations, one of the two. Oh, look at that. I got my double check reminder right up front there before we even get to the answer. All right, so the first technique is very special and has limited use because, can you tell that the bases are the same of my exponential function? Hopefully that you can. So we have this one-to-one property, same base property. That lets me do that. 2 to what power equals 2 squared? If the bases are the same, the exponents are the same. And I just got a pretty straightforward linear equation. I'm going to add the 4, add the 8, get that, divide by the coefficient 9, answer. Double check it, plug it back in the original equation. Does the left side equal the right side? Calculator, calculator, you're good to go. All right, so that next technique, same thing, same base. Now, can you tell that the right side is 11 to a power? Some students can, some cannot. Maybe you might think, and then you go to the calculator and try to figure it out, that's fine. But if you don't immediately see it, I'm going to show you how to do it if you don't see it. But I know that 1 over 121 is 11 to the negative 2. If you can see that, how to turn both of them into the same base, then it becomes a really easy equation to solve. Just set the exponents equal to each other, solve, solve, double check it, like I said before. Okay, but sometimes you can't. There's no way to turn 3 into 2 to an exponent like that. Turn 8 into 2 to an exponent. I can do that. So I'm going to show you 3 different techniques with this same example. And I encourage you to try them out a few times and see which one you like, and then maybe just stick with the one. But if you do get comfortable with more than one, that's a double checking technique. If you solve an equation differently, that's double checking. All right, so this one involves using the natural logarithm. And there are variations on that, but I'm not going to overload you with the variations. Remember, when we're solving an equation, as long as you do the same thing on both sides of the equals, you can do whatever you want. Now, taking the square root on both sides doesn't help us with anything. So I'm going to apply the natural logarithm to both sides. We can do that. We've balanced the equals. Now I've got one of those laws that says you've got that exponent, I can make it a coefficient of the logarithm. So I'm going to use that. On the left side, I'm going to distribute, and I got x's on both sides of the equal sign. Now, pause here for a second and consider how many minuses and negatives you're going to end up with. If you take a second and kind of minimize that, the equation is less complicated. So for example, if I just move the x to the left, like a lot of people always do, I've got to move that natural log of 3 to the right by subtracting. So I'm going to have a minus on the left and a minus on the right, whereas if I move the x natural log 3 to the right, I just have 1 minus. So if you can minimize those things, it's a little bit less complicated. So I'm going to move it to the right. I'm going to factor the x out. And now that big parenthesis, natural log 2 minus natural log 3, is just a coefficient for x. I'm going to divide both sides. I stop here. There are technically 2 more steps that I personally don't think are needed. There's not a single person in the world that knows what number this is. Natural log of 3 divided by natural log 2 minus natural log 3. I don't know. Inches? What? So at some point you got to go to the calculator, and any kind of modification after this to me is a waste of time. Now, on the off chance WebAssign disagrees, I've never had it disagree with me on that. Let me know. But otherwise, this, to my knowledge, when I've practiced with WebAssign, that's an acceptable answer. I'm going to do the exact same example using a different technique. Oh, double check.